Quicksort is a commonly used sorting algorithm. A lot of programming languages use more complex variations of Quicksort as the default sorting algorithm. On the right side of the screen you can see Quicksort implementation using recursion. There's two functions, the recursive Quicksort function starting at line 22 and the partition function on the first line. Let's go through the animation step by step. First it checks that the indices are valid and that the left index is smaller than the right index. This breaks the recursion once we're down to single element partitions. Now we get to the partition function. The goal of the partitioning function is to divide the current partition into two. In addition, it swaps elements so that all the elements in the second partition are larger than all the elements in the first one. We start by selecting a random element as the pivot. There are also other strategies like using the median of 3 and so on. Pivot is highlighted with a white border on the animation. Now we need to move elements around so that elements smaller than the pivot are on the left and larger ones are on the right. The pivot itself could end up on either side. We do this with two counters, I and j. I starts from the left and j from the right. Now we start moving towards the center until the counters collide. The left counter skips elements that are smaller than the pivot and the right counter skips elements that are larger than the pivot. The elements that are not skipped are swapped from left to right and vice versa. Once the counters collide, we return j. J is the index where the partition is split. Choosing j over I is more of an implementation detail. It happens to guarantee that there is at least one element on both halves, because we've excluded rightmost element from being the pivot. Now we do the same thing on the two new partitions and keep going until we're down to single element partitions. The bars above the array indicate the partitioning. You can see the array is now sorted. The performance of Quicksort depends on how well the partitioning turns out. If one of the partitions always has a single element, then we get n squared performance. On average and best case, we'll get n log n performance.